This lesson we're looking at direct and inverse variation. So we're going to start by looking at direct variation. So that's our green box highlighted here. So here, direct variation is when y is directly proportional to x. And we use the formula y equals kx, where k is some constant. And you'll notice that it's a linear line and it goes through the origin. Here's some key things to note about the direct variation is that it's a linear relationship between x and y. Our k value is known as the constant of proportionality. And our graph is a straight line going through the origin, and its gradient is k. This comes from our linear equation topics. Recall that y is equal to mx plus c, and recall that our m value is what the gradient is. So here, what we're doing with our direct variation is we're basically taking this first portion of the equation, because notice that if my y-intercept is the origin, that means that c is equal to 0, so we don't have it in our direct proportion equation. And can you see here that our k value is our gradient? Typically with direct variation, we also work in the first quadrant only, i.e. we're only working with positive values of x. So here, our first example is that for garden mulch being sold in bulk, the cost is C and it is proportional to the volume V in cubic meters. So first thing we want to do is we want to represent this algebraically. So here we're going to start with A, and the first thing I like to do is I actually just like to write the form of the direct proportion, which is y is equal to kx. Now here, then I want to match up what is my y value and what is my x value. So as a rule of thumb, our y value is always our dependent variable. And our x value is our independent variable. So if we look at our equation here, notice that the cost is dependent on, the amount of mulch that we need. So here, our dependent variable is C, and our independent variable is going to be V. So our formula becomes C is equal to KV. So that's our first part A done. Our next part says the shop quotes $270, which is our cost, which is C, for 7.5 meters cubed, which is our volume V. So find the constant of proportionality. So this constant of proportionality is our K value, and graph the function. So here, what I'm going to do is for B, I'm going to use my formula, and instead of writing C, I'll have 270, which is equal to K multiplied by 7.5. So my K value is 270 divided by 7.5, which ends up being 36. Once I find my K value, I normally like to rewrite the equation. So now C, instead of writing K, will be equal to 36V. This K value that we have here, this K here, like the name says, it's a constant. So K is a constant that does not change. So that's why it always remains in our formula here. Our next part is we're going to graph. Recall in the previous slide that it's a linear equation, and notice it's only in the positive quadrant. So that's why I've only drawn this one here. Now, instead of writing y, my dependent variable, I'm going to write c, and instead of writing x, it's my independent variable, which is v. Now, this here is a linear line, and I start from the origin. So I'm going to draw a straight line like this. And then to show the marker that I've graphed it correctly, I'm going to pick a point to label. So let's just say, for example, when the volume is, let's say 1 meter cubed, then the cost of that will be $36. So that's part B done. Part C, it says how much does 12 meters cubed cost, which is our volume. So here I'm going to use my formula. So C will be equal to 36 multiplied by 12. So the cost will be $432. So that's part C. Part D says how much can you buy for $600? So this time we're looking at our cost and we need to find our volume. So 600 is equal to 36 V. So V will be equal to 600 divided by 36. Now this here will give us a recurring decimal. So I'm just going to round to 1 decimal place for this question. And notice this is in meters cubed. So that there is 16.7 meters cubed, which is part D. This here is a practice question. So pause the video to have a go and then come back with when you're ready to check the answers. So for part 2, a supermarket has boxes containing cans of dog food. The number of cans of dog food is directly proportional to the number of boxes. So here, notice that the question will always tell you whether it's direct or inverse. So if we look at part A, it says if there are 144 cans in 4 boxes, find an equation for the number of cans, which is represented by N, and the number of X boxes. So here, what I'm going to start by doing is I'm going to label with my new pronumerals here. So my cans is represented by a capital N, and my boxes is being represented by X. Now here, the number of cans is dependent on the number of boxes we have. So for part A, I'm going to again start with my standard formula, which is y equals kx. Then my y is my dependent. So the number of cans will be dependent on the number of boxes. So here I will have capital N is equal to kx. So here, notice now, I have to now find my constant of proportionality. So here, the next step I have to do, think about it as step 1, you have to form an equation. So that's our first step. And your second step is find K. So now our second step is when I substitute in the values that I've been given. So I have 144 cans, which is equal to 4 times K. So here, therefore, K is equal to 36. So here, it says find an equation. So now, therefore, my equation is going to be capital N is equal to 36x. So this part here, yes, it's an equation, but notice here that I have to find K to make it the equation of this specific question. So here I'm now going to look at, so that's my first A done. I'm going to look at B here. So B says how many cans, so I'm looking for N, are in 28 boxes, which is X. So here B, I'm going to use the formula that I have before. So I'm going to find the number of cans, which is equal to 36 multiplied by 28, which will be 1008 cans. The next part here, so that's B done. C says how many boxes, which is my X, would be needed for 612 cans of dog food. So here I have 612 is equal to 36x. So X will be equal to 612 divided by 36, which will be 17 boxes. And notice that I always finish with the units of measure as well to show the marker that I've answered the question. Now, there are some instances where direct variation isn't always linear. So here, it's not always linear. For example, one variable could vary directly with the square or cube of another variable. So if we look at this gray part here of the table, if y is in direct variation with a power of x, then notice that we get this formula right here. So it's the same as the formula we were using before, except this time x has a power of n to it. So we've got an example here. So if the variation is with the square, it's y equals kx squared. If the variation is with a cube, it becomes x cubed. Square root, it becomes a square root, and so on and so forth. So let's look at this example here. The area A of a pentagon varies directly, so there's that hint again, varies directly with the square of its length x. So when the length is 7 centimeters, its area is 84 centimeters squared. So when it says A, it says find a formula. So here I'm going to start. Now here, normally what I was doing, I was writing y equals kx. However, in this instance, notice that it says the square. So it's actually going to be y equals kx squared. Now here, I have to determine what's my independent and dependent. So notice that the area here is dependent on the length of this pentagon. So it will be k, and let's call the length, we'll keep that x. So x equals the length, and a is the area. And again, that's my first step. I've started with a formula. My second step is I have to find k. So here, I'm going to let a is 84 because that's what they've given us in the question. And here, our x value is 7. So then when I go to solve for k, it will be 84 over 49. So my formula for the area of this pentagon is going to be 84 over 49 multiplied by x squared. And that's my answer to A. Now for part B, it says correct to 1 decimal place, find the area when its length is 13 centimeters. So here for B, what I'm looking for is A is equal to 84 over 49 multiplied by 13 squared. So I have 84 over 49. Now it says to 1 decimal place, so it will approximately be 289.7 centimeters squared because we're looking at area. So that is B done. C, it says to 1 decimal place, we're going to find the length, which is our x, when we know that the area is 156. So 156 is equal to 84 over 49 x squared. So here x squared will be equal to 156 divided by our k value here. So here 156 divided by 84 over 49. Now that actually ends up being 91. However, to undo a squared number, I'm just going to move my working out up here, I have to take the square root. Now, normally when I take the square root, I have a plus and a minus. However, because I'm dealing with length, length is only ever positive. So here I can only take the positive answer. So if I take the square root of 91, and if I look at that to 1 decimal place, that will be 9.5 centimeters. Here we have a practice question, so pause the video to give this a go and then come back when you're ready to check the answers. This fourth question, so as a seed pod grows, its volume varies directly as the cube of its diameter d. When its diameter is 5 millimeters, its volume is 327 millimeters cubed. So here, what I'm going to look at is my first step. As you can see, A says find the equation for the volume in terms of d. So here for part A, when it's direct, I always start with y equals kx, and then I go back to my question and notice it's asking for the cube. So here, this power needs to be 3. Notice that the volume here is dependent on the diameter of this particular seed pod. So here my volume will be equal to K multiplied by, the letter I'm using is D cubed. And that there is our first step. So I formed some sort of equation. Now, because the question has given us a bit more information, I'm going to do part 2 so I can find K. So here the volume is 327 millimeters cubed and the diameter is 5. So K times 5. So then K is equal to 327 divided by 5, which is 65.4. So therefore my equation is V is equal to 65.4 times the diameter. Oh, sorry, I just realized I did forget to cube this. So here it should be 327 divided by 125, which is 5 cubed. And so, sorry, K will be equal to 2.616. So therefore, my final equation will be 2.616 cubed. So that's part A. Part B says find the volume when the diameter is 10 millimeters. So here for part B, I'm going to use this formula here. So the volume is equal to 2.616 multiplied by 10 cubed. So here it'll end up being 2,616 millimeters cubed. Part C, find correct to 1 decimal place the diameter when the volume is 500 millimeters cubed. So here my volume is 500. It's equal to 2.616 multiplied by D cubed. D cubed is equal to 500 over 2.6. Now that there, it does give me a bit of a decimal. So what I'm going to do is here, to undo a cube number, I have to take the cubed root. So when I put this into my calculator, to 1 decimal place, I get 5.8 millimeters. Now we're going to move on to inverse variation. So inverse variation is when y is inversely proportional to x and it looks like a hyperbola. So notice that our hyperbola here is 1 over x. Now in this instance, our k value actually belongs on the numerator. And you can see here it makes a hyperbolic shape in that first quadrant. Important facts to know. It's another way of describing this relationship is y is inversely proportional to x, or vice versa. So here the graph of inverse variation is a hyperbola and it is in that first quadrant. Our example here, so building a shed in 12 hours requires 3 builders. So if the number of builders n is in inverse variation, so notice it mentions the type for us. So here I already know that in my exam, even if I make a little note, so here I know that I'm going to be using this formula here to the amount of time, which is t hours. So the number of builders here is my dependent variable because, and then t here is going to be my independent variable and n is my dependent variable. So here I'm going to start with, for A, it says find the equation for n in terms of t. So here the first thing I'm going to do is I'm going to write y is equal to k over x, and then I'm going to equate my values with what I have in my question. So here I'm going to have the number of builders is equal to k over the number of hours. So then the next thing I'm going to look at, so again, that's very similar to direct. That's my first step, which is finding some formula. My second step is solving for k. So here, my n value, so my number of builders is 3. And my time in hours is 12. So therefore, k is equal to 36, very conveniently for the last few. So then, because it says the equation, therefore I'm rewriting my equation with the value of k in it. So that's my first one. The second B, it says find the number of builders it would take to build the shed in 9 hours. So here the number of builders I can find by doing 36 divided by 9. So it will take 4 hours. Then for part C, how long will it take 2 builders to build the shed? So 2 will be equal to 36 over T. So when I get to this one here, what I'm doing is I'm essentially swapping T and 2. So here T will be equal to 36 divided by 2. So it will take 18 hours for that one there. Like we did with the other examples or other practice questions, pause the video and have a go at practice question 6 and then come back to check your answers. So 6, the faster a car travels, the less time it takes to travel a certain distance. So it takes a car 2 hours to travel to Nelson Bay at a speed of 80 kilometers per hour. So if the time taken, so the time is represented by T, notice again, varies inversely with the speed, then the first thing is we need to find our equation for T. So here, my first step is I'm writing y equals k over x. And here, normally my independent variable is going to be time and my dependent variable is going to be the speed. So here, s will be equal to the constant over the time. So here, that's my first step. So I found that equation. My second step is to find the value of k. So I know here that my speed is equal to 80 and that my time is equal to 2. So k will be equal to 160. So my equation s will be equal to 160 over t. Then it says find the time it would take if we're traveling. So if the speed is 100 kilometers per hour. So here, if I have 100 kilometers per hour is equal to 160 over t. So again, like before, we swap. So I get 160 divided by 100. So the time that it would take would be 1.6 hours. Next, I'm looking for find the speed at which the trip would take 2.5 hours. So here I've got C will be equal to our C question is S is equal to 160 divided by 2.5. So my speed will be 64 kilometers per hour. And remember those units of measure there as well. Finally, my last question, it wants me to graph the equation. Remember that these inverse variations are in the shape of a hyperbola and they are in the positive quadrant, which is our first quadrant to the top right of the Cartesian plane. So here I'm going to have my speed along here on my y-axis and my time here along my x-axis. So here a good idea could be is that notice here that I've got 2 points of call. So here I've got 1.6 hours, gives me about 100 kilometers, actually probably a little bit higher up, gives me about 100 kilometers per hour. And then when I'm at about 2.5 hours, I get about 64 kilometers per hour. So can you see that the shape of my curve is going to go through here? So use coordinates or a table of values to help you graph so that way you can get the correct shape. So therefore I've graphed my equation. Now similar to our direct variation, we can also have powers to our x value. So as you can see here with inverse variation, I can also have x to the power of n. So here I've got with my square, I've got with my cube, and I have with my square root, which is just here.